Hello everyone. Today we're going to talk about inequalities involving quadratic functions. So we've seen a lot of quadratic functions. For example, something like this is a quadratic function. And we have learned how to graph them by several different means. We've learned how to translate graphs, moving them left and right to graph this. And we also learned that we can find the vertex, the axis of symmetry, and an additional point, and we can graph this quadratic. What we're going to do today is we're going to take a quadratic like this and set it greater than or equal to or less than or equal to a number, so something like 7. We might even do something on the right like 7 minus x. So the idea here is we want to find all the values of x where we can plug them into the left-hand side and plug them into the right-hand side and get a true statement. So for example, let's say if we plugged in 1, if we plug in 1 here and we plug in 1 here and we simplify this and we get something that's greater than or equal to whatever's on the right-hand side, then that's a value that works for this inequality. So we're trying to find all of the values that would satisfy this inequality. So that's what we're going to look at today. And the way we're going to solve this is by graphing. So let's look at our first example. We want to solve this inequality x squared plus 3x minus 10 is greater than 0. So what you want to notice here is on the left-hand side you have a quadratic. And since we have a quadratic, we can graph it. In fact, what I'm going to do is I'm going to factor it first. This is something that can factor, and if you look at it, you can see that it factors into x minus 2, x plus 5. Let's double check. So we get the minus 10 here, we get a 5x, and then we get a negative 2x, which add to give us 3x, and then the x squared. So what I've done is I've just taken this piece and I've factored it and made it greater than 0. Now, what I'm going to do is I'm going to graph this. First off, notice that on the left-hand side, if we ignore this piece right here, in fact, let me just scribble it out for right now. Just look at this piece here. How would I graph this? I could graph it using the vertex, and I could determine if the graph is pointing up and then finding an extra point. But something you can notice is you can find the x-intercepts quickly. So if we set this function equal to f of x, and then we set it equal to 0, you can see that your x-intercepts are 2 and negative 5. So let's make 2 points at 2 and negative 5. Because they satisfy this function. When we plug it in, we get 0. Now what are we going to do? I have 2 points that I know, and I also know that the coefficient in front of the x squared is a positive 1. So that tells me the graph is pointing upwards, right? And if it's pointing upwards, the vertex is going to be somewhere between these 2 points. If you go halfway, because remember this graph is symmetric, so halfway, somewhere below these 2 points, because the graph is pointing up, I'm just going to guess, say it's right here, we have the vertex. Now, at this stage, it doesn't really matter where the vertex is. If it's above or below, that's what matters. And I'll explain that in just a second. So I'm just going to guess and say it's right there. I just want the general shape, and I'm going to show you why. So the graph looks something like this. You'll agree with that because we go through 2 points here. We're symmetric, so we have to be halfway in between for the vertex, and the vertex is going to be below these 2 points because the coefficient in front of that x squared is a 1, which tells us the graph is pointing up. Now, what we're going to do is pay attention to this sign right here. This says I want all the values of x that when I plug them into my quadratic function, I get something that's greater than 0. So where is the 0 line? It's right here. This is where y is equal to 0. Okay, where are we on the black graph above 0? So we're above 0. You can see all of these values here are above 0. And all of these values are above 0. So what x values correspond to the y values that are above this graph? Well, if you look down here, I'm going to erase this blue line so I can see a little bit better. If you look down here, you can see that when we're past 2, so let's say, for example, at 3, when we plug 3 into this function here, because this is the graph of that function, when you plug it in, your y value is sitting below 0. So it's above that blue line that I drew. And in fact, anything bigger than 2, even if you get really close to 2, anything bigger than it will have me sitting above that line. And also on this side, anything smaller than -5, if you go out towards negative infinity, anything that you pick, let's say you pick -6, when you graph it, the point on the curve here, you're going to see that you're sitting above y is equal to 0. So that's going to tell us the solutions to this. So the solutions, and we're going to put this in interval notation. So the solutions, so the x values that satisfy this inequality are negative infinity to -5. I'm going to tell you if we're going to put a bracket or a parentheses here in just a second. And then from 2 to infinity. Now, when we are exactly at -5 and we're at 2, we're actually lying on this line, y is equal to 0. And because we want all the values that are greater than 0, we don't include those two values. So we're going to put parentheses right here. So anything from negative infinity to -5 and from 2 to infinity, but not including -5 and 2, will have us sitting above that y is equal to 0 line. Now, if I switch this, if I instead said, when are we less than 0? What you would do is say, well, here's the line y is equal to 0. When are we sitting below that line? And we're sitting below that line from -5 to 2, because anything in between those two numbers will have us down here. So like at -2, you're going to be right here on the graph, which is below the line y is equal to 0. Let's try another one. Here I have the quadratic, x squared plus 8x is greater than 0. Let's see what we can do with this one. Now I want to graph this. This is this part. Let's call this f of x. Now there's several ways I can graph this. I can put a +0 on the end and notice that this is in the form ax squared plus bx plus c. We can find the vertex and we can use the axis of symmetry and extra point to find this. Something I see right off the bat is I can find the x-intercepts. So if I set this function equal to 0, and I don't need this piece really, so let's get rid of that. So if we set it equal to 0, we can factor the right-hand side. And I can see that my x-intercepts are 0 and -8. Because if I plug in 0 and -8 into here, I get 0 for the function. So I'm going to plot these 2 points. One at 0, 0, because when you plug in 0, you get 0 for the function. And one at -8, which is way out here. When I plug in -8, I get 0. So those are my 2 points. Okay, so I know the vertex occurs halfway between these two, which is at -4. And I have to figure out if it's above or below those 2 points. We look at the coefficient in front of the x squared. It's a +1, which tells me that the graph is pointing upwards. So the vertex is going to be at -4 something. At this moment, it doesn't really matter what it is. We can be careful and we can actually find it if you want to. but I just know it sits somewhere down here. So I'm just going to put it there for right now, because that's not going to matter for this problem. All it matters is that it's below. So now let's graph this. So the graph is going to look something like this. Okay, and now that we've done that, now we pay attention to this inequality. Now we want to know all the values that are greater than 0. So again, let's draw 0 here. And let's find the values of x that satisfy this inequality. So when we plug in x, and the x value, we're going to be above this line. And you can see that the x values that satisfy this inequality are negative infinity to negative 8. We don't include negative 8 because when you're at negative 8, you're sitting on this line. And then from negative 8 to 0, we're below the line, so we don't include those. And then from 0 to infinity, we're going to be above this black line. So from 0 to infinity, we're above the black line. So these are the x values that satisfy this inequality. All right, let's move on. This time I've switched the inequality sign. So we have x squared minus 1 is less than 0. Again, I'm going to write this as a function x squared minus 1. Let's set it equal to 0 and factor, which tells me that I have two x-intercepts, one at 1, one at negative 1. So this is negative 1 and this is at 1. And the number in the front is a positive 1, so in front of that x squared, which tells us that the graph is pointing upwards. So I'm just going to guess that the vertex is somewhere around here, and I just really need to know the direction it's pointing. Okay, so now that I've done all that, I have an idea of what the graph looks like. I'm going to put right here that this is a guess. It's not an accurate point, a vertex, but I do know it's somewhere below these 2 points. And now I just need to figure out, when is this graph less than 0? So the x values that satisfy this inequality, we look at our graph, notice that this is y is equal to 0. So our function is below this line from negative 1 to 1. Any x value you choose in between these two values, they're going to plot on this graph down here, which tells you that you're below this green line. So it's going to be from negative 1 to positive 1. Okay, now we're going to look at some more complicated examples. There's actually 2 ways to solve this problem. I'm going to show you both ways. That way you can be familiar with both of them, and then you can choose the way you like the best. So the first way is very similar to what we've done. I'm going to move everything to the left-hand side. So I'm going to move this negative 5 over here. So I'll get x squared plus 6x plus 5 is less than 0. And you can see that the x values that satisfy this inequality would also satisfy this inequality. So if we find the solutions to this one, then there'll be solutions to the original inequality. Okay, now we're going to label this as the function we want, x squared plus 6x plus 5. And let's see if we can factor that. I believe this factors into x plus 5 and x plus 1. So I can see right off that the x-intercepts are negative 5, 0, and negative 1, 0. So let's plot those. And I can also tell that the coefficient in front of the x squared is a positive 1. So the vertex is halfway between these two and sits below somewhere. Again, this is a guess. And that we're pointing upwards. So something like that. And now paying attention to this inequality, we look at this graph, we draw our line y is equal to 0, and then we ask ourselves, when are we less than that 0? Okay, so you would find that the x values that satisfy this inequality are going to be from -5 to -1, and we don't include those two because we will be equal to 0, and we want to be less than 0. Okay, so we solved it one way, and I'm going to put the solution here because I'm going to show you a second way to solve this. I'm going to put the solution right here. And that way, for the second way we solve this, if we get the same answer, then we can see that either way works. So I'm going to erase this. And now what I'm going to do is I'm going to look at this inequality, and I'm going to think of this as the quadratic. And here is a line. So I'm going to have two functions. I'm going to have a function f, which is the quadratic, and I'm going to say that's x squared plus 6x. And we're going to do that one in blue. And then I'm going to have another function, g of x, which is equal to -5. And that's going to be just a straight line. And let me put that here. This is a line. This is going to be a parabola or a quadratic. And let's graph both of these. So I'm going to do a similar method here. I'm going to set this equal to 0, which I'll get x squared plus 6x, which factors into x and x plus 6, excuse me, which tells me that x is 0 and x is -6 are x-intercepts for this parabola. Now this is a different parabola than the one we had before, because before we moved the 5 to the other side. Here I didn't move the 5. So we're going to graph this one. We have an x-intercept at 0, 0, and at -6, 0. For this parabola, the coefficient in the front is 1, so that tells me the vertex is somewhere in between and below these 2 points. Remember, I'm just going to guess, like this. Now, at the moment I'm guessing, but I might actually have to be careful with my vertex. So right now we're just going to say this is a guess. But for this particular problem, we're going to need to be more careful. And I'll show you why in just a second. Now let's graph this line, g of x is equal to -5. Now remember that a line is y is equal to mx plus b. Here, g of x is your y, and m is your slope. I don't have anything with an x here, which tells me my slope is 0. This is a horizontal line. So we need to draw this horizontal line at -5. So here is -5. So this is g of x. And this function up here is f of x. Now I mentioned that I have to be very careful with the vertex. So before I didn't have to be careful, but this time I'm going to have to be careful. And that's because I need to know if these two intersect. And if they intersect, where do they intersect? Because if the vertex is sitting above this, then this inequality, where you want the inequality above this line, so this is what this problem is saying. When is this function less than this line here? So here's the line, and you're going to try to figure out when this parabola is below it. But if I don't know if the vertex is above or below, I can't solve this problem. So I need to figure out the actual vertex, where it's located. So let's see if we can do that. So let's find the vertex. We did find these two intercepts, which is good, but let's see if our guess for the vertex is right. I just put a guess somewhere right here, but let's find the vertex. So the vertex is h comma k, and h is the -b over 2a, and k is the function evaluated at -b over 2a. Now I'm going to add a 0 here to our function, just so I can have it set into that ax squared plus bx plus c form. I really don't need to do that, but in case you get confused, if it doesn't look exactly like ax squared plus bx plus c, just add a 0 for that missing term. So h is -6 over 2 times 1, which is -3. Okay, so that gives us the h value. And then the k value is f of -3, which we're just plugging -3 into here. So we get -3 squared plus 6 times -3. Okay. Which is 9 minus 18, which is -9. So we have a vertex at -3, -9. Now you can see that this guess was incorrect. It's actually at -3, -9, which is way down here. So let's see if we can zoom out a little bit. I'm going to continue this down here. So this would be -7, this is -8, and this is -9. And so the vertex will be right here at -3, -9. So our parabola looks something like this. Sorry, it's not exactly, I'll try again to make it straighter. Okay, well that's as best as I can do it. Again, it looks something like that. It needs to be circular at the bottom. Okay, so here's our parabola, and you can see it's below this line. So the question, let me get rid of this so we don't have too much going on. The original question, if you look right here, was when is this parabola, this one right here, the one in blue, less than -5? And you can see that these two actually intersect right here. We need to figure out exactly where they intersect. And anywhere between those 2 points, our parabola is going to be below -5. Okay, so we're going to say anywhere in between these 2 points. So where do they actually intersect? To figure that out, we just set these two equal to each other. So we set the parabola, which is x squared plus 6x equal to -5. And then we move over the 5 and we factor, which will be the same numbers that we got before. So they will intersect at -5. So when x is -5, and also when x is right over here. Let's do a better job of showing where these intersect. And when x is equal to -1. And we can actually find the whole point. So we only have the x coordinate now, but we can find the point by plugging in -5 and -1 into either function. But you can see, because this is a line right here, this line is equal to -5. This point would have to go through -1, 5, -5. And this point would have to be -5, -5. So you can see that the x values that satisfy this inequality are from -5 to -1, because then you'll be below that line. So it's -5 to -1, which is exactly what we got the first way. So this is a little more complicated, but you get the same answer. And you can see it's like shifting the graph and the line that was here, we shifted them down 5 units. Let's try another one. Okay, so this is problem 5. I'm going to do it in 2 ways. The easier way, I think, and then the harder way, and you can choose which way you like. So here I have 2x squared minus 2 is less than or equal to negative x minus 1. I want to find all the x values that satisfy this inequality. The first thing I'm going to do is I'm going to move everything to the left. So I'll get 2x squared plus x minus 2 plus 1 is less than or equal to 0, because I'm moving these over. So I moved this x here, and I made this positive 1. I'm going to simplify this. This is 2x squared plus x minus 1 is less than or equal to 0. So let's erase this piece. And this is a quadratic, and we're going to label that f of x. Now we're going to try to graph this and see when it is less than or equal to 0. To graph it, I'm going to try to factor it first, see if it's factorable. So to factor this, I'm going to draw an x. I need 2 numbers that multiply to give me negative 2, add to give me 1. I think that would be negative 1 and 2. If you multiply these 2 together, you get negative 2. If you add them, oh, I want a negative 1, so no, I want a positive 1, okay. So I get negative 2, and then I get positive 1. So these 2 numbers work. So to factor this, I'm going to break this up into 2x squared minus x plus 2x minus 1. So all I did was I took this number in the middle, which was x, and I made it a minus 1x and a 2x, which is right here. That's how I use these 2 numbers. From there, I group the first 2 and the last 2, and then I take out the greatest common factor in both, which is x for this one, and then I can just take out a 1 for this one. And you know you did it right when you get the same thing in both of these parentheses, and then the last piece is to factor out this. So you'll get x plus 1. So this is the factored form. So I'm going to write that right here. This is equal to 2x minus 1, x plus 1. And if you're not good at factoring, you can always use the quadratic formula to find your x-intercepts. So that's the other method you could do to find the x-intercepts, because that's what I'm trying to do here. The reason I'm factoring it is because I want to set it equal to 0 and find my x-intercepts. So my x-intercepts are 1/2 and negative 1. But if you use the quadratic formula, you're going to get the same thing. So at 1/2, which is right here, let's zoom in a little bit. You can see 1/2 is here, and negative 1 have x-intercepts. I also want to look at the original function and see if we're pointing up or down, and we're pointing up because this is a positive 2. So my vertex is somewhere below these 2 points, so like halfway. I'm going to say about right here. For whenever we're setting this, we have an inequality with 0, it doesn't matter where the vertex is. It just matters the direction of your graph, and if it's below or above the line, then we focus on this line here, and we ask ourselves, we look at the original inequality, and we ask ourselves, when are we less than or equal to 0? So we're equal to 0 when we're on these 2 points, and we're less than 0 when we're between those 2 points, and these 2 points are negative 1 and 1/2. And we can equal these. So I'm going to put brackets this time because we can equal them because we have this equal sign. So that's the solution. We're between negative 1 and 1/2. Okay. That's the best way to do this problem. I'm going to show you an alternate in solving this problem. And that is by considering this as a quadratic and this as a line. So we have the function f of x is going to be 2x squared minus 2. We're going to graph that, and that's our quadratic. And then we're also going to graph this line, g of x is equal to negative x minus 1. This time we have to be careful with the vertex. Okay, so I'm going to graph this, and I'm going to graph this one. Maybe we're going to graph the line first because it's easier. Let's remember what we have to do to graph a line. This is in the form mx plus b, where m is negative 1 and b is negative 1. So our y-intercept is negative 1, and our slope is up 1 over 1, up 1 over 1, or down 1 over 1. Okay, I'm not very good at, I think what I'm going to do is I'm just draw a bunch of points and maybe do some slashes like this because I have a hard time drawing straight lines. Okay, so this is the function g of x. Now let's focus on the quadratic. I'm going to set that quadratic equal to 0 and factor. And I get 0 is 2x minus 1, x plus 1. So I am able to find the two x-intercepts. There's one at 1 and one at negative 1, 0. I also know that this quadratic is pointing upwards. I just need to figure out where that vertex is. If the vertex is between 0 and 1, or if it's below or actually on that dot. So let's see what we can do here. To find the vertex, I'm going to look at this function. Remember that the vertex is h comma k. This function is 2x squared plus 0x minus 2. Notice that there's no b term here. So this b times x. So your h, which is negative b over 2a, is just 0. So h is 0. Now to find k, we plug in 0 into our function. So our function is here. If we plug in 0, we get 0 minus 2, which is negative 2. So we can see that the vertex is at 0, negative 2. So here is our graph. Okay, now what do we need to do? Let's look back at the inequality here. The inequality asks us, when is this parabola less than or equal to this line, negative x minus 1? So you can see, here's the line, and when are we less than this line? So that means when are we underneath the line? When you have less than, that means you want to be underneath it, and when you're greater than, you're going to be above it. So from right here to wherever this intersects right here, that's when we're underneath that line. So we need to figure out where these two intersect. We already can see where they intersect here, but we also want to find out this point. So how we do that is we set these two equal to each other. So we have 2x squared minus 2 is negative x minus 1. We're going to find two x values. One of them is going to be negative 1, and then we're going to get another x value, and that's going to tell us where they intersect. So I'm going to move everything to one side and factor, which this is going to factor just like we found last time into 2x minus 1, x plus 1. And you can see that x is 1/2 and x is negative 1. So we got the negative 1 here. And this point is 1/2. And if you want to find the y value, you just plug it either into the parabola or the line. I think the line is easier to work with, so we can plug it into there. If we plug in 1/2 into here, we get G of 1/2 is -1/2 minus 1. I'm just plugging it into here, and I get -3/2. So that would be the y-coordinate, but you don't really need the y-coordinate to figure this out. What you need is the x-coordinates. And you can see that when x is between, and I'm going to zoom in some, when x is between -1 and 1/2, which is right here, so between these two x values, you're either sitting on this green line when you graph it on the parabola, or you're underneath the green line. And so our two solutions, actually we're going to have infinitely many solutions, but the endpoints of the solutions is going to be -1 and 1/2, exactly what we got here. Now you can see this one is much more complicated. If you have some homework problems that involve this, and they ask you where it's less than or greater than a line, just remember less than is when you're underneath it, greater than is when you're above it, and you're equal to when you're right on the line. All right. I have, I think, one more of these I want to do, and yeah, and then we're going to move on to something different. So problem 6 says I have 2 times 2x squared minus 3x is greater than or equal to -1. And I want to find the x values that satisfy this inequality. You can have one just like this on your homework. So I decided to do one. Okay, I'm going to solve this one way because I think the very first way that I showed you how to solve this is the easiest. So I'm going to distribute this 2 inside. So I get 4x squared minus 6x is greater than or equal to -1. Then I'm going to move everything to one side. 4x squared minus 6x plus 1 is greater than or equal to 0. All right, now I try to factor this. Now, to me, looking at this is going to be hard to factor. Right off the bat, I can tell that I don't have a 1 here, which is going to make it difficult to factor. We can see if we can factor it. We need two numbers that multiply to give us 4, add to give us -6. So 4 is 2 times 2. You can't really break that down anymore. You can do 4 times 1, but adding 4 and 1 will only give you 5. It won't give you -6. So I don't think this is factorable. That's okay. When something's not factorable, we will go straight to the quadratic formula. So this is our function that we're paying attention to. To find the x-intercepts, we set it equal to 0. Notice that this is in the form ax squared plus bx plus c, where a is 4, b is -6, and c is 1. The quadratic formula says solutions to this is x is equal to -b plus minus square root b squared minus 4ac, all divided by 2 times a. So I'm going to plug in these pieces into this quadratic formula. So the first piece is the -b, which would make this a +6. And then the second piece is the square b, which would be 36. The third piece is to do -4 times a times c. So that's times 4 times 1. And then 2 times a, so we put a 4 on the bottom. Let's simplify this. This is x is equal to 6 plus or minus square root 36 minus 16 over 8, which is 6 plus or minus, this becomes 20 over 8. And you should notice that the square root of 20 is the square root of 4 times the square root of 5, which is 2 square root 5. So this is 6 plus or minus 2 root 5 over 8. And we've done a lot of these, so I'm going pretty fast, but you can see that everything is divisible by 2. So you get 3 plus or minus square root 5 over 4. So our two solutions are right here. And I'm going to write them up here. So x is equal to 3 plus square root 5 over 4. And x is equal to 3 minus square root 5. 3 minus square root 5 over 4. Okay, So these are some weird numbers. We can graph them, but it might be difficult. We're going to see. So I want to, everything looks messy, so let me kind of clean this up. Okay. So how are we going to graph these? These are our x-intercepts. I'm going to pull out a calculator. So I'm going to put in my calculator 3 plus square root 5 over 4, just to get an idea of where that is. So 3 plus square root 5 over 4. It says it's about 1.31. So this is about 1.31. And let's plug that one into the calculator and see what that is. It's about negative 0.1, positive 0.19. Yeah, 0.19. That's about what that is. So we're going to make these dots. So here's 1. This is like a 0.2, which is halfway is 0.5. So let's say it's about right here. And then we have a 1.31. Here's 1. Let's zoom in. Here's 1. 1.5 is about right here. So let's go like right here. And then we look at the original function. We notice that the coefficient is a positive 4. So we're going to have a graph that looks something like this. Okay, and then we just figure out when we are greater than or equal to 0. 0 is right here. So we're above that line when x is negative infinity to 0. And when we're from, oh sorry, not 0, but if you look closely, this x value, which was 0.19. And also from this 1.31 to infinity, we're above that line. So the solution, let me maybe put it in red, is from negative infinity to this 0.19, and I'm going to use the exact formula for this. And we can equal this because this says greater than or equal to 0, union 3 plus square root 5 over 4 to infinity. So that's the solution to this problem. And we use brackets because we can equal 0. And so that's when we're on this line right here, this axis. Okay, something what I want to mention is every time we did a problem, all of these problems, I'm going to go up. You can see that my parabola is pointing upwards. Just happened to be all the problems I gave you. But sometimes your parabola can be pointing downwards. So I just want to talk about that real quickly. Let's say instead of 4x squared, let's say everything was the same, but I had a negative in the front. What would that mean for us? Well, if we had a negative, that would tell us that our vertex is sitting up here because the graph would be pointing downwards, right? Oops. So the graph would look something like this. So when the graph is pointing downwards, that might change your solutions a little bit because the question was, when is it greater than or equal to 0? Well, you can see that we're above the line 0 when we're between these 2 points. So if we had a negative and we had the same x-intercepts and everything, the solution would be from this to this because that's when we are in between them. So the solution would be like that. So you have to be careful about which way your parabola is pointing up, if it's pointing up or down. That will determine your solutions. Okay, so it's not enough just to find the x-intercepts and say, oh, well, we're always pointing up, so it'd be negative infinity to this and then that to infinity. It really depends on the parabola. All right, I think we've done enough of these problems. I want to mention that I think on your homework, they ask you to find the domain of a function like this. Now we learned already how to find the domain of such a function. We said when we have square roots, we always set whatever is underneath the square root. That needs to be greater than or equal to 0. right? So if we had something like f of x, in fact, let me give you a different problem that we've seen before. Say g of x is equal to the square root of x plus 5. So what we did was we put x plus 5 is greater than or equal to 0, and we were able to move the 5 to the other side, and then we said, oh, this is from negative 5 to infinity, if we put it in interval notation. You're going to do the same thing here, but when you do that, you're going to see you have one of these problems that we just saw, where we have a quadratic that's bigger than a number 0. And so you're going to do the same things we did before, where you graph this and you find the solutions. So when you find the solutions to this will give you the domain of this function. Also notice that this one has a negative in front of the x squared term, so this parabola is going to be pointing downward. So this is a good example of what I was talking about here, where you have a parabola that's upside down. So again, you just want to set this equal to 0, find the x-intercepts, and then you're going to plot the vertex halfway between those x-intercepts and above it. So I think we can actually do this one really quickly. This one is x minus 3x squared. We set it equal to 0, take out an x. You get 1 minus 3x is equal to 0. So you get x is 0 and x is 1/3. I think that will work. Yeah. And so you have a point here and also a point at 1/3. And you know that the graph is pointing downwards like this. Here's 0, here's 1/3 right here. And then they ask you when you're greater than or equal to 0. So you would just say, oh, that's from 0 to 1/3. Because that's when you're above this line 0.